Okay, hello everybody. Welcome back to ChemSoc. And today we'll be doing two exciting experiments focusing on explosive chemistry. I'm Nadisha, president of the UWI Chemical Society. And today I also have with me Kasha, which is our chief experimental officer. And Ricardo Price over here. All right, so we will be doing two main experiments, as I said, and we will be looking at the theory behind the experiments as well. So we'll be focusing All right, so guys, so today, as I said, we will be synthesizing nitrogen triiodide, and we will also be igniting some ammonium dichromate and seeing how the reactions work. As I also said, we will be looking at the theory behind how these reactions also work. So we're going to start off with the ammonium dichromate. So we're just going to add some of it to a watch glass, and then we're going to ignite it and watch it burn. So it has somewhat of a volcano pattern, pretty much like a volcano. And of course, we're going to do this outside because we can't do it inside the lab. So we're going to do that first. So let me show you guys what we have here. All right, so there we go. So this is our ammonium dichromate. It's nice and pretty orange in color. We're going to add that to our watch glass, which we have right here. Don't mind the dirt. We're going to add it to the watch glass, and we're going to ignite it, of course, with some matches. We're going to do all of that outside. Well, we can add it to the watch glass now, and then we bring it outside, and then we ignite it, and you'll see what happens. So, all right, so we're going to add some to the watch glass. Well, by some, I mean a lot. Yeah, like a pile in the middle.
I honestly, sorry. Oh,
Kasha,
you want to see?
Kasha's hand
You want
is very light.
to see?
Little bit more. You make it like a volcano shape. Yeah, that should be good. All right. We're going to kind of heat it around like this in the shape of a volcano. Let me get rid of this lump because it probably won't burn so easy. So
Everything's gonna be.
yeah, it will, but like I want a nice, pretty looking volcano. No, we're
No,
not
we're
going to
not
do
doing
it
this
inside. All right, so we're going to bring that outside along with the matches so we can ignite it. All right, let's go. Oh, Javon is here, by the way, guys. All right, so we're going to go outside. It's raining at this point.
Okay, y'all. Y'all ready to witness this?
We're back, guys. So this is our ammonium dichromate again, and we're going to ignite it, basically making a volcano. Ready?
Are you ready?
I am ready.
Ready,
Scene? All right.
Oh well. Let me try.
You have to put it in the middle. And then put the matchstone in the middle.
Yes, no.
Is it too wet? I have an idea.
Multiple matches.
Yeah. But yeah. Nothing you could shoot late the other way.
That's good
It's
enough.
kind of happening. Oh,
This is
I
enough.
should get this.
All right, so as you can see, it's looking like a volcano. The reaction is pretty much carrying itself now. Once you ignite in, then
Oh, that's a lot of ash. That's way too much ash. Is it quite good?
I guess we'll find out.
Oh my, single eye.
That's why you wear goggles.
Oh shit.
Right, so it's kind of dying down now.
Yeah, the ash is clean.
But as you can see, once you just give it a little flame, then the reaction can just carry itself.
The ash killed it.
And there we go. The volcano has finished erupting. And now we have to clean this up.
Oh man. Yeah, it's green.
But the glass
Yeah.
is hot.
It's kind
So
of, let's say, grayish green. Not really.
it's
Orangey
green.
Yeah.
Because remember, it's at oxidation state +6
Yeah.
in the ammonium dichromate. And the chromium is reduced to chromium 3, which is green in color. So that's the end of the volcanic eruption, guys. So we're going to head back and start on the synthesis of our nitrogen triiodide. And we can just let the glass cool for now.
Let's see this.
It is hot.
No.
I mean,
You really want to do that?
no.
More or less.
Well, of course.
Hands up, Steven.
So we're heading back to the lab. And we are going to start the synthesis of the triiodide, which that is our touch powder. While we're doing the synthesis, we'll go through the theory of the touch powder, how it works, why it explodes, etc. All right? So we are starting with the synthesis of the touch powder. We are going to be using iodine crystals, trying this, and we're going to be mixing it with some ammonium hydroxide in this conical flask here. Open this. So we're going to add about what, 30 ml, right, to this mark here. Let me
Oh,
see.
God.
So we're going to add it to this mark here on the conical flask. It's about 30 ml. And then we're going to add the iodine crystals. Yeah. So this is the ammonium hydroxide. And we're going to add iodine crystals to it. About 2 to 3 spatulas is all you need. I use this pencil and get more.
Oh, no, that's for me.
Oh.
Yeah.
No, because that's not enough.
Mhm.
One more.
Mhm.
All right, so looking at the solution, you might see some bubbles or some movement. That's the formation of the product. And the product is shock sensitive, which means when it's dried, if you touch it, then it will explode. So we're going to give it a little stir, a little swirl, I should say. And then after, we're going to let it sit for about 5 minutes so that the reactants can combine. And then we're going to go through the theory of everything that's happening.
Oh, it exploded like
No, when it's
Right. So we're going to leave it to react so that the product can form.
just like self-explode.
All right, so theory time. Let's learn something, shall we? All right, so as I said, we are looking at explosives. So we want to look at some explosive chemistry, and an explosive chemical is a solid or liquid, which is capable by chemical reaction, usually of producing gas at a certain temperature and pressure, and it does so at such a speed that it causes damage to the surroundings. So essentially, you have where these substances undergo rapid oxidation to where they're producing a large quantity of gas. And we know that gases occupy a lot more space than solids, right? So imagine that we're going from a solid, which has a defined shape and takes up a specific amount of space, to a gas that takes up a large amount of space and that has a large amount of distance between the particles, right? So we're looking at nitrogen triiodide first, and this is a touch-sensitive explosive where the weight of the particles themselves can actually cause it to explode. If you dry it enough, it can explode on its own, but it's touch-sensitive. So once it's dried and you touch it, then it will explode. All right, so as I said, it is explosive once it's completely dry, because when it's wet, it's not explosive. And that is because we have ammonia particles or ammonium in solution. So in the conical flask that we would have where we mixed our reactants, it would not explode in that environment. But once you get it dried, the ammonia molecules are no longer present to help it to stabilize the structure, and our nitrogen triiodide structure is very unstable. So once you give it the slightest kind of physical touch or anything like that, it just explodes. And of course, the instability of our nitrogen triiodide is due to the large steric strain, due to the large steric strain as a result of the large iodine atoms that are bonded to the relatively tiny nitrogen atoms. So as you can look on the diagram, the size of the iodine is pretty large compared to a very small nitrogen atom. So we know that we're going to have some amount of steric strain, and the bonds therefore are going to be easily broken so that the molecule can achieve some kind of stability. So we have a low activation energy for the decomposition of the nitrogen triiodide to form a more stable product or more stable products such as ammonia and iodine. So looking at the ignition of the ammonium dichromate, which is what we just did, the volcano, ammonium dichromate is an inorganic compound. As we said, the chromium in this compound is at oxidation +6. And once you ignite it and it begins to decompose, then it moves from an oxidation state of +6 in the ammonium dichromate to +3, right? It is mostly used in pyrotechnics as a catalyst for some reactions and also as a mordant for dyeing pigments. So looking at the equation and essentially what happens when the ammonium dichromate is ignited, because it is thermodynamically unstable, it decomposes on heating, releases nitrogen, water vapor, and chromium oxide, which is green in color, which is what we just saw. So it went from an orange color at oxidation number +6, reduced to chromium 3 in the chromium oxide that we saw form, which is green in color. All right, so our ammonium dichromate is also a strong oxidizing agent. It can react aggressively with any reducing agent. And usually the stronger the reducing agent, the more violent the reaction. So you can use your ammonium dichromate to oxidize alcohols, thiols, as well. So to oxidize alcohols or thiols to their corresponding aldehydes and ketones. So we're going to get back to our reaction at this time. So let me just show you guys what's happening now. All right, so we're going to add some more iodine to the conical flask.
On that side, you use.
This side has dichromate.
Oh, use that.
So we're trying to do it so that we get enough
Mm.
product. We just added some more iodine. Give it a little swirl.
Oh,
All right, so now we're going to vacuum filter our product. So we have turned on the vacuum and added our filter paper inside our button funnel. Oh, the product goes in the bottom. Jesus Christ. That is a lot. Yes.
Open that for me. The aqueous ammonia.
We can rinse them.
Okay. Get some water.
All right, so this
Heat to not make it.
is a lot of
Yeah.
product. We're trying to get some of the moisture out, and then we're going to transfer it to the hot plate to heat it some more.
Yeah.
So it's best to transport it while it's wet or kind of damp, because once it's dry and you touch it, then it will explode. And so we're at the hot plate, and just gonna give it a little bit of heat, not too much, just enough so we can kind of dry out the product.
Get some.
All right. As for the apparatus that we use, so the conical flask, etc., that we use, we have to wash them immediately because we don't want the product to get dry in the conical flask, because then it will just break the flask. So we have to wash it out right away. That's what our product is looking like. It's pretty dark, but I'm pretty sure you can still see the crystals on top. Of course, some of the iodine is going to be left over because the ammonium hydroxide is a limiting reagent. So there we go. 20. All right, so just turned the hot plate to 35 degrees just to give the product a little bit of heat, and then once
Oh,
I love this.
There's that one.
So removing some of the product off of the hot plate, so we don't have too much when we're ready to transport it.
don't touch over the phone. It's like it's a dry.
One is very maybe
So this part over here looks like it's drying. I don't want to touch it. And then it blew up on me. I vote for Jawan to bring it outside. I vote for you to bring it outside. So as you can see, there we go. Great. So you can see now. So those are the crystals of the product. I'm just drying them. Not too much heat, just enough to get them dry. And once they're dry, then the show starts. Oh, one just popped by itself. Kasha, what is wrong with you?
Yeah, 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 you should turn that off.
Kasha forward. Oh gosh.
Turn it on. All right.
Oh gosh.
Start pop on its own.
And you did want to explosive. Oh Lord.
Kasha, earlier they will have them.
Are we gonna do this soon?
Kasha.
Yeah, magnesium.
Oh, someone just popped a while ago.
That one is much more safe.
To make what?
The magnesium.
Oh.
Oh, you can throw magnesium in a
You know,
water.
God, no, unless it's potassium or sodium.
The thing that they do with magnesium is like the magnesium.
And they do it really bright.
Tasha, we have to exclude it, Tasha. I don't think it will hurt it.
It's just going to be low.
Only reason.
Woo!
The one them will touch the hot plate. Tasha gone. Yeah.
Make it drop again, you know?
No. Hmm? What happened tomorrow? Eh? I might have plate this. Oh, I'm not over here to see you. They take this thing hot and no man, don't touch it. Make it go with it. Heat melt it. Don't go by the side, careful. Oh my god. The heat.
Or the heat melted.
Mm-hmm.
But it did turn on. I'll turn it on.
Come tap it, Tasha. Tasha. Lemon. Tap it again.
Mm. Mm.
Ooh. one pencil like a grenade.
Yeah, imagine if you put it in something that's shaky.
Yeah.
You wouldn't even get time to chew it
Oh.
once it's shaky.
No. No.
Oh, that's every much. No man,
Every time I look for a cat, I happen. Here.
and a piece this. Oh,
Yeah.
yeah.
Right? Yes. Some disk?
Yeah.
If it's dry.
Mm.
Shim!
Oh,
Oh, this not wet.
well,
Anticipating more.
mm.
Yep. It's time. Any other stuff you have?
But now
Oh,
I'm
you
done
just
with
step
you.
on it. Oh shit. Ah.
think that's right. Why not running?
It's not very long. Woo! Woo! Jesus! You get that? You get it? Oh. What is Javon doing? I think a sword fight. It's a part of cleanup anyway. That's the only way you can get rid of it. Woo. No man, Kasha, why are you all the way over there? This was your idea.
Kasha, come.
Just one. At least step here.
But you have on shoes.
Realize that when it actually touches the surface of the hot plate, yeah, it explodes.
You can move it though. Are you a tongue? A tongue? Yeah. So we're just cleaning up, guys. This is just clean up. So this is how we're going to get rid of the iodine. And it can even move.
Yeah, the outside.
Alright, so we're taking this little bit outside. And Kasha is running. Should be trying. Not dry. Heat it some more.
Maybe somebody walk past and just step on.
Probably have heart attack. Alright guys, so we're going to heat it some more so that we can ensure that it is dry enough to where it's going to explode.
Step with step.
Oh, to get the fall on the floor. Wow!
I catch that.
Whoa.
Yes!
Oh my god.
Oh,
The ears bust out. Oh, God. Cause no, he might try to take it out. But hold it, did the funny.
everything gone one time.
See what place just get purple.
You know, you don't see the
Yeah. So guys, that's the last of it. That was a big bang to end. We never expect that. Woo, let's eat it. Gone.
Come on, all right.
Look there. It bust up the paper. Eat the shred. It looked like it melts like around 75
Yeah.
degrees.
The moment it touch like 70, it start.
Yeah, that melt. Well, guys, that's the last for today. So, we already know it's question time. It's time for questions. And we will be here cleaning up as well. Oh man, yes. My God. I want to bust the paper fly up. Oh gosh. All right, guys. So on to questions now. Of course, you already know we're going to quiz you to see what you've learned after all of the excitement. Okay, so for our first question now. First question, touch powder can react when it is wet and when it is dry. Is that true or false? Easy question, you know. Easy question. True or false? Touch powder can react when it is wet and when it is dry. And the first correct answer I see is coming from Mikkel. So Mikkel gets that point. Of course, we know it is false because we can see with our own eyes that it doesn't explode when it is wet. So we actually had to give it a little bit of heat, and then when we touch it, it explodes. So question two. What are the decomposition products of nitrogen triiodide? What are the decomposition products of nitrogen triiodide? What does it give off at the end? Let me see some answers. Let me see some answers. Let me see some answers. The first correct answer I see is coming from Michaela. So the answer is iodine and nitrogen gas. Not sure how you would get ammonia, because remember guys, we're starting with Ni3. So there's no way we can get ammonia with that one. So it is iodine and nitrogen gas, and the correct answer is C. So Michaela gets that point. Question 3. So for question 3, the question is, what color is ammonium dichromate? People, these easy question this. What color is ammonium dichromate? It is indeed orange. See, Andre, I'm not sure if you mistook the product for ammonium dichromate, but the dichromate is what we started with, the bright orange crystals. And then when we ignited it, then it would produce the chromium oxide, which that would be the one that is green in color, right? So the correct answer is B, that is orange, and Michaela gets that point as well. Let's go to question 4. So question 4, what is the oxidation state of chromium after decomposition of the ammonium dichromate? What is the oxidation state of the chromium after decomposition of the ammonium dichromate? Let me see what the answers are. I don't know what Michaela used type, but my gosh. So Michaela is correct again. The correct answer is D, that is a +3 oxidation state. So we did say that the chromium goes from a +6 oxidation state in the ammonium dichromate to a +3 oxidation state in the chromium oxide that was produced. Let's go to question 5. How many electrons do all group 1 elements have in their outer shell? Easy questions, these, you know. Easy some things. Let's see what the answers are. Let's see what the answers are. Let's see if we can get a correct answer. I'm seeing some answers. All right, so the first correct answer I'm seeing is from Jophine. The correct answer is 1, which would be B. So Jophine gets that point. Hi, Jophine. Yeah, so it is 1. Group 1 elements have 1 electron in their outer shell. Easy questions, you know, people. Let's go to the next question. Let's see who will get that point. I think we're at question number 7 or 6. I don't even remember. But does the first ionization energy increase or decrease descending group 1? Does it increase or decrease when you go down the group? Let's see some answers. And the correct answer is B. It decreases down the group, and I think that was Miguel. Miguel got that one correct. He was the first to get it correct. So your ionization energy in group 1 decreases down the group, and that is because the atoms increase in size. So the atomic radius increases down the group, and so the attraction between the electrons and the nucleus is not as strong. So it's easier to pull off the electron from a larger atom in group 1, that is. So let's go to another question. I think there's at least one more question left. if I am not mistaken, I believe that one more question is left. Yes, last question. Ammonium dichromate is a strong what? Let's see who's gonna get this one. It's a strong what? Okay, I see some answers coming in. So your ammonium dichromate is indeed a strong oxidizing agent. Similarly to how you have potassium dichromate being a strong oxidizing agent. And obviously, as we had said, that the chromium moves from a +6 to +3 oxidation state, which means it is reduced, and which would also mean that it is an oxidizing agent. So I think Michaela got that correct. And if I am not wrong, Michaela has got 5 points. I think Joffin got 1, Mikael got 1, and Miguel got 1. Correct me if I'm wrong, but I think that's the correct point standings. And of course, we will verify all of that. All right, so guys, today, that is the end of club today. I don't know about you, but me did have fun. It was really exciting today. Of course, our explosive chemistry theme extends to next week. So next week we will be meeting here again for club. We will be doing other experiments. You may have been wondering why I was asking about group 1 elements. That is because we were supposed to do an experiment today about or relating to group 1 elements in water, that is alkali metals in water, but we didn't get to do that today. But I'm pretty sure you guys can agree that today's club meeting was pretty exciting, and I look forward to seeing you guys next week. So we're having club next week. We won't be having club throughout the examination period. So next week is our second to last club meeting for the semester, because we want to have something real nice and special for you guys to end the semester after exams, where we can have fun without being stressed and without thinking that we have to go study. So we'll do that after exams, but next week we will have more experiments like these. So of course, remember to follow us on Instagram at ChemSoc and subscribe to the YouTube page. Thank you. Remember to like the video. You know all of them YouTuber things there? Yes, those things. And I will see you guys next week. And remember, experiment with a chemist and you will love the reaction. Bye.